Okay. Namaskar. After considering the line and surface integral, now we will go through a very simple integral which is known as the volume integral. Therefore, volume integral. Now remember that when we integrate over the volume element, we have considered that the volume element in Cartesian coordinate system dv is equal to dx dy dz. It is the scalar term and therefore the volume integral is always of a scalar function. There is no dot or cross in between f and dv. It is volume integral. With one example, f is equal to 2x square y plus z square, and in a Cartesian coordinate system a volume of a rectangular box, we will consider how to solve the volume integral. Let for simplicity we will assume the rectangular box somewhere here. Now this is our rectangular box. Okay. Now what is the position of the rectangular box? Rectangular box is this axis, x-axis, y-axis and z-axis. These are the points, correct? These are the points. The box is at a distance or along y-axis with an offset of 2 and whose length along y-axis is of 4. Whose length along x-axis let it be of 3 and length along z-axis is of 5. Okay, therefore the box is situated at y is equal to 2. Here, this is the base corner of the box. The length of the box along x-axis is 3. The breadth is along y-axis which is 4 and height is 5, but it is not at origin. It is slightly along the y-axis at a position of 2 and I will have to integrate over this, right? I shall begin with this. Therefore, what I will have to do? I will have to write the volume integral, and we know that the volume element consists of all the three terms x, y, z. Like the surface consists of 2 and therefore though it is single line, actually the volume integral is over the three elements x, y, z. It is 2x square y plus z square. And what is dv? dv is dx, dy and dz. Now according to the convention, the order of variables and order of integral signs are same if there is no extra bracket. Therefore, first line represents the integration is over x and our x varies from 0 to 3. Therefore, it is 0 to 3. Second is for y and y varies from, it will not vary from 0 to 5 or 4. It varies from 2 to 6. See, this is 2 plus 4. Therefore, it is 2 to 6. And our z varies from 0 to 5. That means to cover the entire volume, what I will have to do? I will have to begin with a small element here, then I will have to keep it here, and I will have to cover the x line from 0 to 3. Then change the value of y slightly from 2 to next up to 6. And similarly for z from 0 to 5. Correct? And that is nothing but integration. Now once I write this, now it is very simple. It is just a mathematical calculation afterward. But again, I cannot integrate directly with x, y, z simultaneously, and therefore I will split. I will begin with the integration over x, and hence I will write it is integration 0 to 3 of 2x square y plus z square dx. Then I will integrate over y, and therefore I will write here it is y and integration 2 to 6. And after calculation of this integration, I will integrate over z. Therefore, I will write here it is z integration from 0 to 5. That means first of all, I will solve integration over x, which is from 0 to 3. Then I will integrate over y, which is from 2 to 6. And then I will integrate over z, which is from 0 to 5, and hence it is 0 to 5. See, I have reversed the order. It is 0 to 5 first, then 2 to 6, and then because I am using the brackets, correct? Therefore, I will keep it as it is, integration 0 to 5, then the bracket, integration 2 to 6, then the bracket, and I will have to solve this integration, correct? I will have to solve this integration. Here I will write it is dy and here it is dz. Now I will solve this integration. First term it is 2x square y, integration over x with respect to x is, it is 2x cube y upon 3, correct? 2y is constant, integration of x square with respect to x is x cube divided by 3 plus z square is there and z is constant and integration over x is z square into x, and this is from 0 to 3, correct? That means wherever there is x, I will have to substitute 3. Remember that y and z are constant and therefore I will not change the values of y and z here, correct? Therefore, the next step will be integration 0 to 5, integration 2 to 6. Then I will have to substitute the upper limit. There is no need of substitution of lower limit here. If it is x is equal to 3, then 3 into 3 into 3, 27 into 2 divided by 3. But 27 divided by 3, it will be 9. Therefore, 9 into 2, it is 18. It will be 18y plus, if I substitute x is equal to 3, then it is 3z square. Now, I will have to write it is dy and it is dz. Okay. Now, remember that solving the line integral, surface integral or volume integral is not difficult. It may be complicated. Patiently, you will have to solve systematically, correct? You will have to write each and every term as it is. See, I am writing this integration, this opening bracket, this integration, this opening bracket, then intermediate term, then closing bracket, and so on. Okay, now what I will have to do? I will have to integrate this term over y, keeping rest of the terms as it is. Integration 0 to 5, opening bracket. I will have to integrate this over y. Therefore, it is 18y square divided by 2 plus 3z square y, and that is from 2 to 6, correct? That is from 2 to 6, and then I will have to integrate over z. That means wherever there is y, I will have to substitute 6, I will have to substitute 2, and then I will have to take the difference between them. I will write it is integration 0 to 5, this bracket will be open. Now I will have to substitute 6, I will write it is 18 into 6 divided by 2 plus 3z square as it is, and it is 6. Okay, this is one term, minus, I will have to substitute 2 instead of y, therefore it is 18 into 2 divided by 2 plus it is 3z square into 2, correct? 3z square into 2, then this closing bracket, it is dz. Okay. Now why it is bit complicated? Because I have considered it is integration from 2 to 6. I have shifted the position of that block. If it begins with 0, then it was very simple, correct? But to understand how to solve this in this situation, we have considered this. Okay, fine. Now you will have to calculate. Here it is 9, then it is 36 into 9, it will be it is 324, you may check once, plus here it is 6 into 3, it is 18z square, minus, I will have to consider this 36 plus it is 6z square, okay, and this is integration from 0 to 5 over dz, correct? Actually I will have to solve this. It is 324 minus 36, therefore here it is 8, 1 carry is there 4, then again it is 8, 1 carry, it is 2, you may check once, plus it is 18 minus 6, it is 12 z square, and integration is over dz from 0 to 5. I shall begin on the other page, search for the blank page. Okay, fine, this is the blank page with me. Okay, we shall continue this. Therefore, this is equal to, it is volume integration of f into dv is equal to, now I will have to integrate 288 plus 12z square with respect to z from 0 to 5. Therefore, it becomes 288z plus 12z cube divided by 3, and this is from 0 to 5. Correct? This is from 0 to 5. It's fine. Therefore, I will have to substitute upper limit. There is no issue of lower limit. Therefore, it is 288 into 5 plus, here it is 3 4s are 12. Therefore, it is 4 into z cube, that is into 5 into 5 into 5. Correct? And you will have to solve this. Now, you may solve this. Obviously, better to check this once. Now, the way with which we have used this or with which we have solved this is correct. Just you will have to confirm the calculation. That means just you will have to confirm the product whether it is correct. Now this will be the volume integration of f dv. Now you observe that the calculation of volume integration is simple, but it is complicated. You will have to calculate patiently. And same thing is there for the calculation of the surface integration and line integration too. Thank you.